Hi students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for ninth standard students. Subject is mathematics and it is part 2 of your textbook. And today's video is without any numbers. That is mathematics without much numbers. Yes, this topic is mainly about introducing you to how to approach geometry lessons, paying tribute to father of geometry, Euclid. Let us start the lesson.
So, dear students, let us begin the lesson. Once again, I would like to show you the front page of your textbook and as well as the content concept in the textbook, like logical proofs and logical reasoning are one of the important component of this textbook. This video is related to that because the first lesson, basic concepts in geometry, is telling you about how exactly we should approach geometry. Geometry is full of logical statements, converse, theorem, proofs, along with that different types of shapes, diagrams and its properties. Just like triangle, rectangle, circle, whatever you have studied in the extra years will be explained along with the other diagrams and properties. So in such a situation we need to have certain kind of approach and knowledge to understand that. That's why this particular chapter, as I told you at the beginning, this part of the lesson is not much about numbers and all, but about a conceptual approach towards the textbook. First thing to be mentioned is about what is meant by this conditional statement, otherwise what is meant by the converse of such statement. The statement which can be written in the if then format is normally called as or named as conditional statements. For example, if there is a statement like this: if the given quadrilateral is a rhombus, then its diagonals are perpendicular to each other. So there are two terms which I already mentioned: if and then. That means if this particular condition is there, the other will be the result of it. Such statements are called conditional statements. It's a part of our day-to-day life and as well as in approaching certain problems in mathematics. The if part, which is named as antecedent, and the result part, which is named as consequent. This much you should understand. There are statements with condition. If this condition is followed, that will be the result, or if this condition is existing, that result can be demanded or argued. Regarding the converse of it, by interchanging the conditional statement, whether the resulting statement, whether it stands true or not, is a different thing. The resulting statement is called converse statement. Converse is having a meaning that just we are interchanging the statement to argue upon. It is not sure that that statement will be true. For example, the given statement was, if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. So in these two conditions are there. If the given quadrilateral is a rhombus, the diagonals are perpendicular bisector. This particular property of rhombus you have studied last year. When we think about the converse of it, if the diagonals of a quadrilateral are perpendicular, that particular quadrilateral is a rhombus. That is the converse of it. And in this case it is true, but there is no guarantee that every time it will be true. But here we are studying about making such a statement and its converse. Here the converse is also true. In certain cases it won't be true. Here is another statement which is not that related with geometry or statement. If you get good grades in the sense of good marks, then you will get into a good college. It's a conditional statement. And if you got into a good college, we can very well say that you must have got good grade, good marks. Here also the statement, conditional statement and converse are true. Why these kind of things are given in your mathematics textbook? Because in geometry, and especially in certain situation where we have to prove something with the help of known facts and theorems, we need to put this kind of statements to prove it. To say further, if we consider another statement, if a number is a prime number, then it is even or odd. It can be even or odd. That's the meaning. We know that prime numbers are those numbers which can be divided by itself and by 1. Like 1, 2, 3, 5, it goes like that. So in that 2 is an even number, 1 is an odd number, and 3 is an odd number. So the statement is true. If a number is a prime number, then it is even or odd. But if you make the converse of it, if a number is even or odd, then it is a prime number. This won't stand. The statement is true. The first statement, conditional statement given was true, but its converse is false. That means all even and odd numbers are not prime numbers. Again, this kind of situation will be used to prove by stating something contrary also we can prove something. Okay, so this is a very important methodology adopted in geometry in order to go further. If it rains, the grass will become wet. Everyone knows that. If it rains, the grass will become wet. बारिश गिरे तो grass wet हो जाएगा. But if the grass is wet, it is by rain. ऐसा नहीं बोल सकते. दूसरे रीजन से भी गार्डनर अगर पानी डाले तो भी ग्रास वेट हो सकता है. So you please keep in mind, and we have to connect this with mathematics and especially geometry. Geometry was developed in many nations in different periods for different reasons and constructions, but Greek mathematicians are famous. Thales and many other most famous mathematicians were born and brought life to mathematics in that land. They made the pyramids, and in the making of it, the properties of triangles, and by taking the shadow of the pyramid, the height of the pyramid can be calculated. All such lot of interesting things happened at that time. Even Indian mathematicians also contributed a lot to develop mathematics to this stage, and especially Bhaskaracharya, Aryabhat, Varaham here are all famous in this particular aspect. So they have done valuable contribution to the subject of geometry. That is what I want to say. But father of geometry is Euclid, again a Greek mathematician. At such a time, almost 300 BC, 300 BC means almost 2300 years back, he developed this branch with then known informations and situations, and he could put forward certain postulates or principles which was the really the foundation for development of this branch of mathematics. Hence he is named as father of geometry. And further, his postulates are statements, in fact, which is taken to be true without proof. Certain things are like that. ऐसा भी कुछ होता है ना, इसको proof नहीं चाहिए. Human beings walk with 2 legs. There is no need of any such requirement of proof for it. So there are certain things which by the statement itself is true, so it is proved. Such postulates he put forward in connection with the development of geometry, and such statements along with logical arguments got converted into permanent theorems in this subject. So you need to know certain postulates which are made by Euclid at that time, such as there are infinite lines passing through a point, which we had done लास्ट वीडियो में दिखाया था आपको. एक पॉइंट से बहुत सारे लाइन पास हो सकते हैं. And second, another activity was there which was telling there is one and only one line passing through 2 points. All these things were, or these postulates were put forward by Euclid at that time. A circle of a given radius can be drawn taking any point as its center, and all right angles are congruent. When we say right angle, we have to bother about angle only. Whether it is drawn in the book, it will be small. On the screen, it will be big. On a blackboard, it will be quite big. But angle will be 90-degree right angle, and all will be congruent. Such interesting statements or postulates were put forward by Euclid. If two interior angles formed on one side of a transversal of two lines and add up to less than two right angles, then the line produced in the direction intersect each other. थोड़ा लंबा postulate. You have studied about parallel lines in 7th standard. Parallel lines which will never intersect. And you have also studied about transversal. आपको याद करने के लिए मैं ज़रा इधर डायग्राम ड्रॉ किया. And we also studied about the property that these are interior angle, the sum of interior angle, this is 1, if I name it as 2, 1 plus 2, the measure of the angles total must be 180, which in the postulate it is written as 2 right angles. 2 right angle bole to ho gaya na 180. So the statement is saying that this interior angle which I have marked over here, if the measurement of two interior angle in such a situation, what situation? There are two lines, there is a transversal. If it is less than two right angle, less than 180, the lines will intersect. Intersecting line के explanation में it is given that it will intersect, it will meet. So this angle will be less than 180. That's a postulate. Now we know it, and we know it because all these were started much before, and we started getting the final conclusion, theory, and proof of it. So these postulates were building stones of this branch of mathematics, and a lot of theorems developed out of such postulates. Something which is true and which can be logically proved, we call it as theorem. In order to make theorem, we need to make arguments to prove that. Such arguments are called proof. So you will be making mathematical statements and arguments in order to prove something if something is asked to prove in geometry. नहीं तो भी proof बोले तो ऐसा एक meaning है ना, proof चाहिए तभी, then it will be believed. In proofs also there are two types of proofs. One is direct and another is indirect. Direct proof means you will be directly applying the mathematical principle and proving it. For example, in your textbook there is an example given. The opposite angles formed by two intersecting lines are of equal measure. Opposite angles formed by two intersecting lines are of equal measure. Now, if this is asked to prove, we have to have two intersecting lines. These are the opposite angle. One pair of opposite angle. This is another pair of opposite angle. We are asked to prove that these are of equal measure. That means if this is 1 and this is 2 and this is 3 and this is 4, we are asked to prove that 1 is equal to 3, 2 is equal to 4 because they are the opposite angles. So to prove that, we will be applying certain theorems we studied, principles we studied. Here in the textbook, the intersection is named as O. The angle is AOD here, AOC here, BOC here, BOD here. We are asked to prove AOC, this angle, is equal to the angle BOD, that is this angle, as well as BOC, we can prove that equal to the angle AOD. Now, in order to prove this, we need some proofs. We have studied about linear pair. Linear pair is a set of angles on a line which will constitute together 180. Pair means 2. Total will be 180. This you have studied. So that we can apply here if you are considering this angle AOC and the angle BOC, this angle. Here is a line and here it is linear pair. Here it is linear pair. This is the line. So we can state that angle AOC plus BOC is equal to 180. Reason, angles in linear pair. The same way, angle BOC, that is this one, which here I have marked as 2, BOC plus angle BOD, this is BOD, that is also coming in linear pair. Look here, you can see that. So in that case, what happens? It is just like this one is 1 plus 2. You can say 1. This is 1. I am naming this angle as 1. 1 plus 2 is equal to 180. Again, we are saying that 2 plus 3 is also equal to 180. That means 2 became common, that we can say that 1 is equal to 3. So the next line we are saying AOC plus BOC is 180 because of linear pair. BOC plus AO, which are angles, again 180. In that case, we know that this BOC, which is common, eliminate that. So we can say that AOC, this one, is equal to BOD. So that is what is asked to prove. So we can prove that AOC is equal to BOD. Similarly, we can prove this also. BOC is equal to AOD. So the statement that opposite angles formed by two intersecting lines are equal can be proved step by step using geometrical principles. This is the first one you are doing. You have to do many such sums in coming days. But here, more than doing the sum, the approach you should understand. With given knowledge, we are arguing, we are placing conditions, we are making statements, we are making conclusions and proving it. This is the approach of geometry. That is what I want to tell you. And this is a direct proof because we are applying the known things and as well as we are trying to prove the given theorem or statement directly. Sometimes we cannot prove it directly. For example, here is another situation, indirect proof. Here, the conclusion is contradictory with what is given. You will understand what is this indirect proof just by attempting the problem here. The problem or question given or the statement is prime number greater than a prime number is greater than 2 is odd. Prime number है greater than 2 है odd भी है. A prime number greater than 2 is odd. Very simple statement. We have to prove it. By imagining we know that prime number भी होना है 2 से बड़ा होना है तो the number is next to the number 2, it is 3. But how to prove it geometrically or mathematically? For that, we should follow the statement. If P is the prime number, we are imagining, we don't know the prime number, we are imagining P is the prime number, greater than 2 is greater than 2, then it is odd. This is the condition given or statement given. Now, we know what is a prime number. That prime number is a number which can be divided by itself and 1. So here this number P is divisible by 1 and P only. Then we are asked to prove P is an odd number. We don't have a direct method to prove or direct idea to prove P is an odd number. So we can think in the other way. We are trying to prove that P is not an odd number. ये prove करने को निकलेंगे हम. P is not an odd number. तो वो कैसे prove करेंगे? If P is not an odd number, then P must be an even number. Only two types of numbers are there, odd and even. So if P is not an odd number, it must be an even number. If it is an even number, it must be divisible by 2. But statement दिया है, क्वेश्चन में दिया है P is a prime number greater than 2. तो ये स्टेटमेंट नहीं खड़ा नहीं होएगा कि P is not an odd number because it is an even number. If it is an even number, it is divisible by 2. So that statement is contradictory. So 1 and P are the only divisor of P. In that case, the P cannot be an even number. So we could not prove it. So both statements became contradictory, opposite to what is given. So as we could not prove that P is not an odd number, we have to say that P is not an odd number. We could not prove that. So therefore, the assumption is that P is not odd is false. This proves that the prime number greater than 2 is odd. क्योंकि वो हो नहीं सकते. So this kind of approach. So what is actually happening is we are, or the textbook is trying to make you understand how to approach geometry. Geometry, most of the questions are approached by this kind of arguments, statements, conditions, proofs, theorems are used to get solution or get the proof for the given statement. So my dear students, you should be ready for such things in this year, ready to accept this kind of approach, which is mainly depending on logical proofs, logical reasoning, already set theorems, and already which we are going to learn such more theorems. All these will be incorporated in order to understand this branch of mathematics. That's all from me in this video. Rest of the things will be coming in the next video. Go through the video again and again. Clear your concept. There are certain questions given to write the converse statement and other statement in the textbook. You can attempt it. Later I will be giving you the solution for the questions, but don't wait for that. You can start attempting yourself, and it's a methodology. Okay, thank you. And rest of the things will be explained in the next video. You watch the video again and again, make the concept clear to you, try to get the answer for the question given in the practice set. I will be posting the solutions later. Thank you. So that's all from me today.